This is Itty. Itty whacks it. He's hit more sixes than anyone else this season. Some of these have had disastrous consequences. This is Liam Livingston. Liam Livingston whacks it. So the question is, who whacks it harder? Welcome to Coding in Cricket, where we use our passion for cricket and very basic Python skills to answer questions that no one really asked. In July of 2021, Liam Livingston hit Harris Ralph one of the biggest sixes ever recorded in international cricket. Allegedly, the ball travelled 122 metres at Headingley. Let's see if we can find out how far Itty hits it. The plan is to track the cricket ball's location throughout a series of frames to deduce how fast the ball left the bat and the angle at which the ball left the bat. With these two bits of information, I'll be able to estimate how far Itty's six travelled and compare this value with Liam Livingston's six against Pakistan. The code to get started is really simple. For the frames between when the ball leaves the bat and the ball leaves the screen, I save the frames in grayscale and then crop them such that I'm only including the areas where the ball could be found. Once I've done that, I end up with something that looks a bit like this. With the frames saved, I use a for loop to iterate through the frames and compare them to the previous ones. The code compares the value of the pixel at a given location with the same location for the previous frame. If the values are similar, it leaves the screen black, but if they've changed, the screen turns white. Here's what that looks like. Looking at one of these difference frames more closely, we can clearly see the bat, but it looks like there's two balls. This is okay. The right-hand area shows where the ball was in a previous frame but now isn't, while the left-hand area shows where the ball is now but wasn't in the previous frame. There's a dark band in the middle because the images are blurred. There's a region where the ball was in both frames. From these difference frames, I simply take the ball's location as being the pixel that's white and is located closest to the top left-hand side of the image. Once I have the ball's location, I can use Pythagoras to work out the total distance in pixels that the ball travels across the 20 frames. I can then change this scale to meters by referring to the original video clip. I know how high the stumps are in pixels and in meters, so I can translate between the two. The video I took the frames from was shot at 240 frames per second, so my 20 frames last a 12th of a second. I divide the distance by this time, and I get the speed that Itty hit the ball, about 29 meters per second. Using SciPy to find the line of best fit for the ball's locations, I can then work out the angle that the ball was struck from the gradient of the line of best fit. Itty struck the ball at 42 degrees to the horizontal. A ball with an initial velocity of 28.5 meters per second travelling at 42.8 degrees to the horizontal will travel about 82.6 meters before landing. So it's a big six, but Itty, that's nowhere near Liam Livingston.